Welcome back. Today, we're going to flip a powerful mental math technique on its head and see what happens. It's a really cool twist. Okay, let's dive right in. You might remember from a previous explainer how we tackled dividing by a number like 98, something just below a nice round base number. We used its complement, 02, and a really simple addition process to get the answer in one clean line.
But that begs the question, right? What happens when the number is just above a base? Does the whole elegant method just fall apart if we're trying to divide by something like 11 or 102? Or is there another trick up our sleeve?
Well, the answer comes from this beautiful Vedic sutra called Parivartya Yogyet. It sounds fancy, but it just means transpose and apply. And believe me, that simple phrase is the key to unlocking this whole other set of problems.
This slide really lays it all out. Transpose and apply. What does it mean in practice? Well, with the old method for 98, we had a deficit of 2 from our base of 100. That gave us a positive multiplier. Easy. But for 102, we have a surplus of 2. So we transpose it, we flip its sign, and our multiplier becomes -2. And that one little change flips the entire process. Instead of adding, we subtract. It's like the other side of the same coin.
So let's actually do one together. 234 divided by 11. Now, as you see in step 1, 11 is 1 more than our base of 10. So we transpose that surplus of 1 into a multiplier of -1, which we write as 1 bar. From there, the steps are pretty much the same. We bring down that first digit, 2, we multiply it by our negative multiplier, and then we add that result to the next column, which, is just a fancy way of saying we subtract. We just repeat that process and we're done.
And there it is. Just like that, we've got our solution. The quotient is 21, with a remainder of 3. No long division, no calculators, just one simple line of work. Pretty neat, huh?
Ready for another one? Let's try 482 divided by 12. Okay, so our base is still 10, and the surplus this time is 2. So our multiplier is going to be, 2 bar.
All right, so we apply the exact same method. We bring down the 4. Now, the key step is right there in the middle column. We take our first quotient digit, 4, multiply it by our 2 bar multiplier. That gives us -8. Then we add that to the 8 that's right above it, and what do we get? 0. That gives us our final answer, a quotient of 40 and a tidy remainder of 2. See? You're already getting the hang of it. Let's do 139 divided by 13. The divisor is 13, our base is 10, so our multiplier is going to be 3 bar. Following the same logic, you already know the drill. We end up with a quotient of 10 and a remainder of 9. It's amazing how fast this is once you see the pattern, isn't it? Okay, so far our multipliers have just been single digits. What about something a little bigger? Let's try 3182 divided by 112. The principle is exactly the same. Our base is 100. The surplus is 12, so we just transpose that to get our new 2-digit multiplier, 1 bar 2 bar. Now, I know this one looks more complicated, but trust me, the logic holds. We bring down that first digit. Then we multiply it by our 2-digit multiplier, 1 bar 2 bar, and we just place those results under the next 2 columns. We just repeat that process for the next digit of our quotient. And after all those subtractions are done, the answer just emerges. The quotient is 28, and the remainder is 46.
All right, last one. Let's do one more just to make sure this is locked in. How about 4321 divided by 112? Go ahead, take a second. What's our base and what's our multiplier? Well, the base is 100 and 112 is 21 over, so our multiplier is 2 bar 1 bar.
So we work it through with that 2 bar 1 bar multiplier. We use the exact same process, repeated multiplication and then column by column subtraction, and we arrive at our answer, a quotient of 35 and a remainder of 86. See? Even with a trickier multiplier, the method itself stays perfectly consistent. So let's just quickly recap the main takeaways here. This whole thing is really just a mirror image of the other method we learned. The only big difference is that we use the surplus from the base, which makes our multiplier negative. And that means our main action becomes subtraction instead of addition. As you can see, it's crazy efficient for divisors with small digits just above a base, like 11, 12, or 103. Now, here's the one place you have to be a little careful, the signs. It's an easy place to trip up. When you have a multiplier like 1 bar 2 bar, and you multiply it by, say, 2, you have to remember that every single digit of that product becomes negative. So the result isn't negative 10, it's negative 2 and negative 4, which we write as 2 bar, 4 bar. Getting that one little detail right is the absolute key to making this work every time.
You know what's so cool about this is how a simple change in perspective, just transposing a positive surplus into a negative tool, solves a whole new class of problems just as easily as the original. It really makes you wonder, doesn't it? What other math rules are just waiting to be bent or flipped about by simply looking at a problem from the opposite direction?